Hi, this is Mrs. Baxter, and today we are going to start learning about linear inequalities. So hopefully you have your notes handy or you can at least follow along. But with linear inequalities, they're very similar to actually drawing a linear equation. And instead of finding solutions where x marks a spot, we are now going to be looking at regions of the coordinate plane or regions of our graph that have a boundary line and have multiple solutions. So a linear inequality is what we mean by that. And you'll start understanding as I give you more examples. This is more of the vocabulary part. But the solution of our linear equality are the shaded areas. Areas and points. I'm going to get rid of the of and the points that make the inequality true. Okay, and as you guys remember, a coordinate or an ordered pair, same thing, is always in x, comma, y format. Okay, so as a review, the equation for a line is our y equals mx plus b. When you see an inequality, you're still going to see a y-intercept. Remember, if you don't see a y-intercept and you just see this, you're going to start at your origin. But this is going to tell you where to start. This is going to tell you your slope. This is going to tell you what direction to go, okay? But instead, now we're going to start seeing a different sign in here with an inequality, okay? So for your first step, what you're going to do is you're going to plot your line, just like you did before. You're going to look for your slope and your y-intercepts. Then you're going to connect the dots using either a dashed line or a solid line, okay? This is what's going to tell you what to do. So if it's greater than or less than, then you're going to write a dashed line. If it's a greater than or equal to or less than or equal to, you'll see this line underneath. You're going to do a solid line. Now, in class, you're going to hear me say, if you see a line, draw a line. So if you see a solid line underneath this greater than or less than, you're going to draw a solid line. If you don't, it is going to be dashed, okay? So really quick review, let's practice. When we read inequalities, we're going to read from left to right. And we're always going to do, if you remember back to elementary school, kind of the alligator sign. He's hungry. You're going to want to eat the side that's the biggest and has the most food, which in this case, 35 is greater than. So you're going to write your symbol like this, greater than 10. And then the one below is 10 is less than 20. And we're going to flip our little alligator sign to the other side. And that's the less than sign. So remember, reading left to right. All right, so let's do some examples on the back. Let's flip to the back here. All right, these are two examples of what we're going to start doing with our inequalities, okay? In our first example, we're looking at this equation right here. And this line that's drawn is y is greater than x plus 1. So you'll notice that 1 is our intercept. And when there is not a number in front of our x, remember it's just my favorite number 1, you're going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. So this line is that equation. The only thing that's different now is this. So if you remember from the front, we have a greater than sign. So if y is greater than, you're going to shade above the line. Okay, because it's saying that everything above this line, that your y right here, this y, look at y-intercept right here, y is greater than this whole line, okay? So when we do that, you can see that the shading all occurred right here. Now, the reason why you see this -3, 2 is because that is a possible solution to this linear inequality. Anywhere in here is a possible solution. Now, one place that is not a solution is outside the shaded area. Not a solution. So this, not a solution, okay? Now, here's something that I want to make sure that you understand as well. anything that is on the line, right here, right here, right here, right here, all of these points on the line, Do you think they are or are not a solution? Well, they are not solutions because the solution is not equal to the line, okay? It's saying it's above, it's greater than that line, all right? So you can only have solutions that are in the shaded area. It can be bumped up right next to it. It just can't be on the line. It doesn't include it. Okay, so if you have an equation like this, y is less than negative 1/2 x plus 2, let's make sure this is where our y-intercept is, right? 2. And then it says we're going to go down 1 to the right 2. Down 1 to the right 2. Yep, they've graphed this. This is our line. Now, also notice they've done the dashed line because it's not equal to. And you're going to graph or shade below the line. Because, remember, our y is less than the line. So look right here, our y is less than this line, okay? So everything down here is going to get shaded. All right, let's look at another example. In this instance, we now have this less than or equal to sign here. And so because it is less than or equal to, you're gonna shade everything below because it's less than the line. Now, something that's different than the ones up here at the top, here and here, because we now have this equal sign, this point here, any point on the line is now included in the solution. So this is part of the solution as well as any point in the shaded area is in the solution. This, not a solution. This, not a solution, okay? But this is a solution. This is a solution, all right? All right, last example here. If y is greater than or equal to, again, we have a solid line. Notice it's solid. We're going to be greater than or equal to, and we're going to shade above this line. Again, y is greater than, so we're going to go up. This is a solution, this is a solution, this right here, not a solution, okay? All right, so now you should be able to get to the homework and start working on that. If you have any questions, let me know. Thanks.